I'm so happy to be here to share my experience in the field of investigation of antifungal effect of Chitosan-barijeh essential oil in nanocomposite components. I want to stop my camera to decrease the noise and start the speed of my speech.
Yeah, that will be fine. Yeah, that will be fine.
Thank you. This is a project by me and my student in Semnan University during the last 3 years. We have published several reports on potential of ferula, gamosa, antibacterial and antifungal activity up to now. So come back to traditional medicine. Global epidemics and newly emerged pathogens like COVID-19 pandemic made us to think more about traditional medicines that are based on the application of natural products mainly obtained from locally grown herbs and plants in every country in special season. Some kind of traditional medicines is aromatherapy as a practice of using essential oil for therapeutic benefits. Essential oil are generally recognized as safe, and many plants produce essential oils, but in the family of Apiaceae, it's very enriched in actually sulfur contained essential oil is associated with problems due to low solubility in water, high volatility, and sensitivity to temperature. It decreased its application in medical application. On the other hand, essential oil may be added to biopolymers, materials like chitosan, to enhance their antimicrobial effects. Chitosan is a biocompatible, sustainable natural material with uniform polysaccharide of N-acetyl glucose chain joined by beta acids that have interesting and unique antimicrobial properties. Chitosan is a natural polysaccharide with characteristics such as biodegradability and non-toxicity, which can be used as a carrier in nanoencapsulation. But I'll come back to our material method. Ferula gamosa as the biggest genera in the Apiaceae family was selected since this family could produce wide range of aromatic compounds rich in terpenoids. Accordingly, Ferula gamosa could accumulate bicompounds such as alpha and beta pinene and other parts of the resin, volatile oil, gum, and resin are the main three components that make up oleo-gum resin in this plant. Ferula gamosa essential oil show strong antibacterial effects in vapor phase against different bacteria. On the other hand, chitosan, the composite of essential oil and chitosan, may enhance the antibiotic properties of such materials. So have a look brief in our methodology. The resin obtained from cutting the root or bottom of the stem of Ferula gamosa plant. The aqueous distillation method was performed using a Clevenger device, and the essential oil of resin oleogum were extracted, and the essential oil was mainly composed of alpha-pinene and beta-pinene, sulfur-containing compounds, many of monoterpenes. Moreover, chitosan was converted ketene was converted to chitosan using thermochemical method. To prepare chitosan, grown particles of shrimp and crab shells were exposed to sequential treatment process of demineralization, discoloration, deproteinization, and distillation. Synthesis of nanocomposite were done as chitosan was added to the aqueous acetic acid solution and stirred for 30 minutes. Then Ferulla essential oil was added to the homogeneous mixture. TPP was dissolved in distilled water and added dropwise to the homogeneous emulsion and stirred for another 30 minutes to form the suspension. Finally, nanoparticles were collected by centrifugation and dried at 80 centigrade. Both the chitosan ferulla essential oil composite and chitosan finally stored at 4 degrees centigrade to study the characterization of nanocomposite experiments such as XRD, FDIR, FESM, TEM, EDAX mapping were performed to examine the physical characteristics of the sample. During the synthesis of nanocomposite, we use different conditions such as different ratio of TPP and different ratio of chitosan to essential oil that's summarized in this table. And the results of antifungal activity on Candida albicans is tabulated here. As you can see, the most, I'm sorry for some misspelling here in the table. The most stronger antibacterial activity was achieved in treatment number 3 with a zone inhibition of around 13 millimeter, which is available here in this picture. This 13 millimeter inhibition zone is comparable with commercial antibiotics that it's very promising candidate. In conclusion, combining essential oil with different carriers is a step toward preserving essential oil against degradation. Chitosan has performed the dual function of antibiotic and stabilizer. FDIR, TM, and XRD result confirm that the chitosan nanoparticles with the average size of 50 to 250 nanometer were synthesized and the ferulla essential oil was embedded. We hope this research will broaden the utility of ferulla gammosa source and provide a new perspective on biomedical application. These findings probably shows that ferulla essential oil could be effectively loaded in chitosan to further facilitate its utilization in the food or medical industry. And I would like to thank you for your attention and give me this opportunity to talk about our research in Semnan University.